So, today is February 11th, and we're taking a look at equations of circles. So the good news is this is going to feel a lot more like algebra class. So if you're not comfortable with geometry, you'll be very happy with this. If you hated algebra and love geometry, let's just pretend we're still in geometry class then. All right? So equations of circles. We're going to start by first understanding where they come from. So what happens is there are what are called four conic sections. All right? And conic sections come from when we take what's called a double-naped cone. So we take a cone in space. And a double-naped cone just means you have two cones that are kind of attached like this at the point. And we slice this, we can get various different shapes. So the first way we're going to slice it is if we go ahead and slice parallel to this side right here. We'll end up with a shape that looks something like this. Please try to the best of your ability. Yes? It is called a parabola. Very good. You guys have seen this before? So again, this is what it looks like from head on, and this is called a parabola. We're going to spend at least 2 days on this. All right. Another way we can cut it, this one's a little bit easier to see here. So if I cut it parallel to one of the bases, I get a shape that looks like this. From the side, or from straight on, we can see that it is a circle. This is the one we're going to be interested in today. There are two others. I'm going to show them to you, but know that the last two we are not going to discuss in this class. We're going to keep them for you for Algebra 2. If we tilt our cut and slice it this way at an angle, we end up with, we call it an ellipse. Yeah, tomato, potato. All right, so an ellipse, and I'll be honest, I don't know if it's spelled with one L or two, so I just use 3 to be safe. All right, so we can have an ellipse. Nope, that's not what happened. All right, and then last but not least, if we cut it perpendicular to one of the circle bases, so this final cut here, this one's a little harder to draw, so please bear with me. Yeah, guys, there's nothing to be lost on yet. Everybody just calm down. I'm showing you how you can cut a cone and get 4 different shapes. All right? And this is not my best drawing, but this one's called a hyperbola. All right? So essentially, just to recap here, we take a double-naped cone, so that's a 3-dimensional shape in space. And depending on how you slice it, you can get one of 4 shapes. These 4 shapes are called our conic sections, right? So again, if I cut it here, I get a parabola. You've seen those before in Algebra 1. You studied them when you did the chapter on quadratics. Nothing too surprising here. We're going to spend 2 days on the parabola, but we're going to approach it very differently than what you saw in your algebra class, okay? If we cut it parallel to the base, we get a circle. We're going to spend at least 1.5 days, if not 2 days on the circle as well. You're going to find it's a lot easier than the parabola, so we're going to do that one first to kind of ease us into conic sections. We will not discuss ellipses or hyperbolas in this class, other than what I've already shown you. They just come from different slices of that cone. All right? So parabola and circle, those are the two we're interested in. Today, we're interested in circles. So let's go ahead and regroup and take a look at what we already know about circles. Yes, ma'am. What's that? Yeah, so just imagine perspective, right? We know if you look at the top of a cone, it looks like a circle, right? But that's not a very good circle either. That one's also oval because we're looking at it from an angle. So again, this is a 3-dimensional model, but I only have 2-dimensional paper to represent it on. So that's why it looks like an oval. but if you were to look straight down, it would be a circle, whereas the green one would still be an oval. So here, a circle. I'm going to draw a circle again, and so far I've been pretty lucky. They've turned out pretty good today. As you will find, drawing circles can be a little challenging. You guys are really nice. Yes, that is the perfect circle. I'm glad you all agree with me. All right, so here, perfect circle. This middle point is called the center of the circle. What's interesting is it's not part of the circle, okay? It's right. The circle itself is these points on the outside, but we use the center to define the circle because all of these points have one thing in common. They are the same distance from the point in the center. We call that distance a radius. Very good. So there's a radius. The radius is simply the distance from any point on a circle to the center of the circle. Now you guys also know that if I go directly from one side to the other through the center, that's called a diameter. Okay? And again, this point right here is called the center. Okay? There are other special segments on a circle. Next chapter, we're going to get into what are called tangent lines, secant lines, chords, all different types of things. But for now, these are the ones I need you to know is the radius, the diameter, and the center. Okay?
Wait, you said next week?
Yeah.
As in like 7 days from today?
No, you're right. I'm sorry. Quiz this Friday, test next Friday, week after that. So 2 weeks. So we have here a diameter all the way across, radius from center to outside, and center is the point in the middle. Okay? So what is a circle? A circle, by definition, is the set of all points equidistant. Seen that word before. Same distance from a center point in the coordinate plane. Now that last piece there, in a coordinate plane, is pretty important. It might seem trivial, but if we were to just have this in space, we would actually be defining a sphere. A sphere is all the set of points equidistant from a singular point, but by placing it in a plane, we've now made it a circle. Okay? Some things we know about a circle. We know the distance around the outside of a circle. What's the distance around the outside of a circle called? Fantastic. So the circumference is equal to 2 pi r. And of course, area. Good. Now, there's a couple different ways to remember this. Area in general is a two-dimensional measurement, which is why we have the only measurement being squared. Whereas circumference is a one-dimensional measurement, which is why we just have r as the only unit here with any dimensions. So here, squared is area, single r is circumference. All right. Those aren't going to be too important. I just need to know that you know those formulas because you have learned them previously. Yes, ma'am.
So the arm represents like wherever we plug in the number, right?
Specifically the radius. Yeah, absolutely. The length of the radius. All right. So what we're going to do is we're now going to derive the equation of a circle in the coordinate plane. So again, I'm going to draw another beautiful and perfect circle. I know, you're impressed. I get that. It's actually a contest out in Las Vegas where they award money to the person who can draw the most perfect circle. No. There's videos online. It's insane. The one dude, I swear, he unhinges his arm, walks up to a wall. You can't see this on the video, sorry. But anyway, the guy like walks up to the thing, like puts his arm against the wall, and then just goes, and straight up circle. It's insane. Yeah. He basically uses his arm like it's a compass and just gets crazy with it. Sorry. But anyway, my circles are pretty good too, right? So here, we're going to go ahead. We're going to call this center point. We're going to label it HK. This is a convention we like to use in math, where we use the center as being HK. Now we know the circle itself is all the points on the outside.
Pardon the interruption. Can I please have Ramley Hernisen packed and ready to go?
Absolutely.
Thank you.
So here, the circle itself is the actual points around the outside. So we want a relationship between those points, which we're going to call x, y. Question? That's hk, and that's xy. All right. Now, to derive a formula, we know that all these points have to be the same distance apart. So we're going to define that distance right here as being the radius r. Now, we know from our study on distance formula and Pythagorean theorem that we can set up a very clear relationship between these. If I go ahead and drop an altitude down here and then connect it horizontally, I get these two legs of a right triangle. Now here, this horizontal leg, what's the length going to be? Well, it's the horizontal distance from this point to that point, so I'm going to express it as being x minus h. This is x minus h. Sure. So here, remember when I tell you to find the distance between two numbers in the distance formula? I say, all right, well, what's the difference between those two on the number line? Distance, you want to think difference. So if I subtract two numbers, I can find the distance on the number line. So I'm simply doing x and subtracting h to figure out that length. Does that make sense?
Because it's half of r.
No. Think of it this way. What if they were actual points? Let's say the center was 3, -7, and the point on the outside was 9, 5. How would I find this distance right here between these two? Well, I would say from 3 to 9 is how far? 6. We're subtracting. 9 minus 3 is 6. From -7 to 5 is how far? It's 12. 5 minus -7 is 12. So you can kind of convince yourself using points like that. But here it's just the difference between the two x values. So what's the vertical distance going to be? Good, y minus h. We like to put the y one first. Technically it is indifferent, but that's why we're going to do it. All right? Put the y first. Yeah, put the y first. Good. All right. So now here, what's the relationship between these two legs and that radius? Well, it's a right triangle. So the relationship is x minus h, the quantity squared, plus y minus k, the quantity squared, equals the radius squared. So this is y minus k. No, it's k. Now it's just a blue blob. But yeah, it was a k. Okay? No, you heard me wrong. If only there was a video recording. Delete all. All right, good. All right, so here's our equation. Now, specifically, this is the equation of a circle that is centered at hk and with radius r. That's really it. That's all there is to the equation. Microphone can hear everything you say.
Really can.
Absolutely. All right. I tested in one of my earlier classes. Yes. Centered at HK with radius R. Yeah.
Wait, so you can hear us?
Yeah.
Who?
I can. Anybody who listens to the tape can. No.
So you're giving, why are you recording this?
I was asked to. That point is HK, so the vertical distance will be y minus k. Sounds like a great question for after class. Examples. Yeah. So here, there's essentially going to be two types of problems. There's going to be problems where I give you an equation and I ask you for some information. Or there are going to be problems where I give you some information and I ask you for the equation. That's really all it boils down to. So let's go ahead and take a look at the first type. I'll call this example 1. And we're going to go ahead and say find the center and radius of the circle and graph it. You're going to find graphing is very easy once you found the center and the radius. I'll show you. Okay? So we'll go ahead, we'll label this first one here A. And I'll go ahead and tell you the equation is x minus 2, the quantity squared, plus y minus 3 quantity squared equals, and we'll go with something easy like 16. Okay. So this is what a problem's going to look like. Don't worry, I'm going to show you. What's that? I'll go back on this one too. So here, x minus 2 squared, right? When we take a look here, our equation was x minus h, the quantity squared. So what's in the place of h? Good. Now here, we've got y minus k, the quantity squared. What's in the place of k?
3.
3, very good. And then finally equals r squared. So what's r squared? 16. So now it's pretty straightforward, right? The center is simply the point hk. So you guys already told me, what's h equal?
2.
What does k equal?
3.
Nailed it. That's the center of that circle.
Wait,
Why did it not
can you do
be
that again? Because I'm still writing.
Yeah.
This is why would it not be negative?
Well, what does the equation say? It says x minus h. So what number is being subtracted from x?
But it
Positive
would be
2.
negative if it was like parentheses.
There's lots of different ways to think about this. That's the mathematical explanation. I'll show you in a second on the next one, the mathematical explanation. But for now, here's the way I teach it that students remember. When it comes out of the parentheses or goes in the parentheses, it changes its sign. So here, x minus 2, the minus 2 comes out. When it comes out, it changes to a positive 2. Y minus 3, minus 3. When the 3 comes out, it becomes a positive 3. All right? Now the last part, r squared equals 16. If r squared equals 16, what is my radius going to be? Very good. R equals 4. All right? Sure. So take a look over here. What does it say r squared is? Yeah, so if r squared equals 16, I take the square root of each side, r equals 4. Okay.
So for the center, you just take whatever's in the h and k spot and make it positive?
No, I don't make it positive. I see what h equals, I see what k equals. When it comes out of the parentheses, it changes signs.
And so then,
So let's take a look at another example and see if that clarifies your question. Example B, x plus 1, the quantity squared, plus y squared equals, let's go with 20. Very good, Miss Sullivan. K is 0. What's being subtracted from y? Nothing. So k is 0. Now here's the interesting one. Remember, this is x minus a number squared. Now this says x plus 1. How can I rewrite that as subtraction? X minus what number is the same thing as x plus 1? Negative 1. So now you can see what's the value of h? Negative 1. So the center,
How did you get x?
what's minus a negative? So I just did that backwards. It's a positive. I turned it into minus a negative. Really shouldn't. If it's stressing you out, you're overthinking it, I assure you. So here, plus 1 on the inside, what's going to be on the outside? That's it. That's the easy way to do it. Right? Here it was minus 2 on the inside, so out here it became positive 2. Here it was minus 3, became plus 3. Plus 1 becomes minus 1. Essentially. Another way you can ask yourself, what makes this equal 0? What makes this equal 0? Question, Ms. Rafferty? We'll walk through it again in a second. So now here, what's being subtracted from y? 0, so there's going to be nothing. All right? You guys go ahead and work on the radius. Find the radius for me. You know I want it in simplified form, so go ahead and find the radius.
But I'll figure it out. I'll figure it out.
All right, against my better judgment, I'm going to call Mr. Soriano. What'd you get for the radius?
I'm still figuring it out. I really do.
So what does r squared equal in this case?
It equals 2.
R squared equals 20. Very good. I'll take the square root of each side. You're right. It breaks down to root 4, root 5. So I know what r equals 2 root 5. All right. Good. So there's the center. There's the radius. Any questions? So we said r squared equal to 20. And then we took the square root to determine what r was. And then I simplified the square root of 20 down like we have been. All right. Now there's one thing we're neglecting to do. What's the second half of each problem say you're supposed to do? Graph it. We have not graphed anything. All right. So let's go ahead and take a quick look at how we would graph these. The first one's pretty easy to graph, right? If I go ahead and go to my coordinate plane, I know I'm going to skew a little bit towards quadrant 1. So I'm going to do the same thing here. Just skew a little bit towards quadrant 1. Sure, sorry. Now the center, I'm going to go ahead and find the center, which is 2, 3. That means I'm going to go over 1, 2. I'm going to go up 1, 2, 3. There's the center. Sure, I just plotted the point 2, 3. Over 2, up 3. Now, the radius of 4, it can be hard to go ahead and pick a point that's 4 spaces away from that all the way around. So we're going to focus in on 4 points that are easy to graph. From the center, I'm going to go right 4, I'm going to go left 4. I'm going to go up 4, I'm going to go down 4. This will give me 4 points that my circle has to go through. So first I'll go over 1, 2, 3, 4. There's 1 point. And I'll go back. 1, 2, 3, 4. There's the other point. All right. Everybody calm down. The radius is 4. So I know all the points on the circle have to be how many spaces away from the center? 4. So I went 4 to the right. I went 4 to the left. I know there's points there. I will go 4 up next. Let's do that. 1, 2, 3, 4. Where else am I going to go? 1, 2, 3, 4. 4 down. Now I have 4 good points for my circle. My advice, as you come across these points, make sure you're going horizontal at the top and bottom, and you're going vertical on the left and the right. Guys, what's it like being perfect? I mean, I'll never know. Guys, you do your best, all right? It's pretty hard. A lot of us like to criticize before trying things. All right, so here is our circle. All right. Now the second one's a little bit trickier. Let's talk about why. Good old 2 root 5. How far is it 2 root 5 from something? I don't know, right? A decimal? I'm not going to let you do that, unfortunately, because I'm mean. Let me show you what I'm going to have you do. All right. This one is going to skew down a little bit, so I'll pretty much just go with a normal coordinate plane where I can see everything left, right, top, bottom. Pretty happy with that. All right. Now I'm going to start by finding the center, which is negative 1, 0. So here's negative 1, 0. All right. Now I have to go 2 root 5 from each of these. Now this is where it helps to actually think about it when it's in unsimplified form. Square root of 20. The square root of 20 is between which 2 perfect squares? 25. Very good. 16. Very good. Now what is the square root of 16? 4. And the square root of 25? So I know it's somewhere between 4 and 5. Now 20, it's pretty much right in the middle. It's a little bit closer to 16, but not by much. So if I had to guess this number, it's going to be right around 4.5, a little bit less. So that means from those points,
We could do that.
absolutely.
Like, what if they're worse numbers, and we can't just be like, oh, it looks like half.
You're going to do your best, right? At some point, you just have to, right? If this was square root of 18, 18 is pretty close to 16, so I'd go a little bit more than 4. Square root of 5, I'll go a little bit more than 2. Yeah, use your best estimate. Now here, I'm going to go ahead and go down, what do we say? 4.5. So let's go over 1, 2, 3, 4, 5. We'll back it up and go 4.5. 1, 2, 3, 4, 5. 4.5. And then we'll go down 1, 2, 3, 4, 5. 4.5. 1, 2, 3, 4, 5. 4.5. Those are my 4 points. If you weren't impressed with my last circle, oh, you will definitely be impressed by this one. Stewie has an oval head. This is obviously a perfect circle. All right.
Beautiful.
So does anybody have any questions on how we steal the center and the radius from the equation, and then how we use those to graph the circle? All right. Like I said, there will be some numbers that you're going to come across that aren't going to be as pretty as, a center of 2, 3. But use your best estimate when graphing. I'll be fairly understanding since you guys are new to that. But finding the center and radius should be a piece of cake. The second type of problem, example 2, is doing the complete opposite. So we take a look at the last problems. I gave you an equation. I asked you for information. For these problems, I'm going to give you information. You're going to write the equation. So these will say write the equation. From the information provided. Example A. Make this one pretty easy. Tell you the center is at -3, 2. And the radius is equal to 2. So our answer for this is going to be an equation, right? Now the first part of that equation is always x minus h. If this is -3, what am I going to write for x minus h? Very good. Remember, it changes signs whenever it leaves or enters the parentheses. So that's x plus 3 squared. Plus, what am I going to put next? Very good. Equals, on the other side, 4. Perfect. Easy enough, right? Sure. The radius squared, right? In our equation, it's always r squared. So whatever the radius is, square it. And that's the number that goes there. So here our radius was 4. 4 squared is 16. Here our radius is 2 root 5. 2 root 5 squared is 20. Down here our radius is 2. 2 squared is 4. Okay. Pretty easy, right? All right. I can make it a little bit harder. Not much. I could go ahead and tell you instead the center is at -4, 7. And a point on the circle is -1, 11. Now again, I'm picking numbers that make this work out pretty nicely. So the last one's pretty easy. I gave you the center, I gave you the radius. This one I'm giving you the center and a point on the circle. So what do you want to know that I haven't told you? The radius. Now think about what a radius is. What does a radius connect? The center to all the points on the circle. So how can I find the radius? Very good. So go ahead and do the distance formula from the center to the point on the outside and find your radius. A lot of people looking at me and not writing in their books. That is not what I got. Yeah. Well, so far, you keep going. 5, very good. Yeah. So real quick, let me show you a quick trick. When I look at the equation, I don't actually want to know r, right? What do I actually want to know for my equation? R squared. So if you want, you don't even have to take the square root when you're done, right? I know that the radius squared equals delta x squared plus delta y squared, right? That's just like my distance formula, except without the square roots. So here, r squared is going to equal, what's the distance from -4 to -1? And then what's the distance from 7 to 11 for delta y? Now if I square 3 and I square 4, I get 9 and 16. Add them together, and you get 25. So r squared equals 25. Now I can take the square root. Take the square root, r equals 5. That one's easy. But I don't need to, because what does my equation have in it? R squared. So I'm trying to replace r squared with 25. So let's go ahead and write our equation. You guys go ahead and write your equation now that you know that information. And then I'll call on somebody. To be honest, it'll probably be Mr. Salome. Somebody want to call on somebody. Could be anybody. It'll probably be him. We're now writing the equation. So now we know the center. We found the radius squared. So now we're looking for an answer that looks something like this from the previous problem. Okay. Yes, right? So remember, this is the equation of a circle, which is a relationship. So there has to be an input and output variable. So x and y should always appear in your answer. You got this, Cece. Sorry. New plan. Not calling on Khalil. No, got somebody else I'm going to call. Could be anybody. I don't worry about the floor. You just put that paper anywhere. It's not a big deal at all. Yeah, literally, I'll just strip that out of your notebook. All right. Let's just call on somebody at random. Miss Smith. You got this. All right, Miss Smith. This center is -4 here, so what am I going to put with x? If it's -4 on the outside, good. X plus 4.
And then y minus 7.
All right, nobody likes to show off, Miss Smith. Calm down. I'm just kidding. And what is that going to equal? R squared, which is? Perfect. Nailed it. All right. I mean, that's really as hard as you can get. I mean, unless... Well, I guess that would be mean. Think that's it? Let's just see what happens. Just one more. You guys think this is bad. What do you see tomorrow? All right. Endpoints of the diameter. If you were going to be sick, my advice, not tomorrow. All right. I'm tampering around with completing the square. You don't want to miss that. Yeah, so this one's being really mean. So we know if I want to write the equation, I need 2 pieces of information. Pretty consistently, we wanted the center and the radius. This time I gave you neither.
Okay. Thank you.
You're welcome. So how can I find the center? Let's start there. Mr. Fugo. Absolutely. If you look back at the picture you drew in your notes of the diameter, what's exactly in the middle of the diameter? The center. So we're going to start by doing the midpoint to find the center. So the center will equal -2 plus 4 divided by 2, comma 6 plus -2 divided by 2, comma. So the center is 1, 2. All right. Now it's just like the last problem where I have the center and I have 2 points. You get to pick. Both are going to give you the exact same radius. My advice, though, always find the center first and then go center to endpoint. Some people like to go endpoint to endpoint and then divide it in 2. That works out great if you get a nice clean number. But if you're trying to cut the square root of 35 in half, not so nice. So my advice is definitely go from center to endpoint. You'll see it's exactly the same thing. So here we're going to use radius squared again. Delta x squared, how far is it from 1 to 4?
3.
What if I went the other way? What if I went 1 to -2?
3.
Still 3, so it doesn't matter. How far is it from 2 to 6? How far is it from 2 to -2? So you can see you get 3 squared plus 4 squared again, and we already know that that equals 25. So now I go ahead and write my equation. Go with x minus 1 squared plus y minus 2 squared equals 25. Very good. Any questions there? Now I recognize that it would be very cruel of me to assign homework when you guys already have that other assignment due tomorrow at 8.
Yeah, and mine keeps making me
I'm looking at you.
a real man of God. I didn't throw that out.
But I am a cruel man. So there is another homework assignment on Canvas.
But it's due Wednesday.
I'll tell you what, I'm a reasonable man. Let's cut it in half. You want to do evens or odds?
I don't want to do it.
Evens it is.
Yeah, how many questions are there?
It'll be 10 if it's just evens. What? But you checked Canvas because you knew we were going to be here. I specifically got an email saying anything that's not on Canvas, please email me. I'm like, oh, it's on Canvas. She's got it. I will stop it. It was there all weekend. Lion McLagerson. It was there Friday, first period. You can ask anybody in my first period class because it was there. It's alright. It's not doing until tomorrow at 8.
In the morning. Not at night. Yeah, 8 in the morning. And if